Hey guys and girls, welcome back to the shop. My name's Gary, and today I'm going to do a small repair on the Camelback Drillpress, something I've needed to do for a while, and it's going to give me a little more functionality out of it. When I got this drill press from the previous shop owner and moved it out of his shop, the access door was too low to move the drill press out. It's probably probably 7 foot tall, maybe a little more than 7 foot tall, and it was probably 3 or 4 inches short getting under that door. So the drill press had to be laid down. We had to winch it up on the trailer, and when we did, this lockout arm up here got broken. So I'm gonna make a repair to that and get this functionality back. What the lockout arm does is it allows this spindle feed arm to be locked out of position for when the power feed is being used. So I haven't been able to use the power feed on the drill press. Also, it's used to lock out that arm so we can do rapid spindle moves with this other feed arrangement on the left hand side of the drill press. So let's go over and take a look at the part, and we'll get to fixing on it. So this is a broken piece off of the Camelback drill press, and this is the part that mounts up near the top of the drill press that holds the large feed arm up out of the way and disengaged so you can use the power feed. It's got the cogged wheel on the side that the large arm engages into, similar to a Bridgeport spindle feed, but it's even larger. So this mounts up top, and you can see a little wear spot there where the trigger on that large feed handle rubs against that when you lock it into place against this rod here. But during the move into my shop, when we went and got it, this got broken. Basically, this handle got up against something, so it broke the casting. So I need to bevel all of these edges here so they'll take the braze material. And also another thing I'm going to do before I braze it, after we've got the edges beveled, is I'm going to take a torch and heat these parts up 3, 4, maybe 5 times and wick out all of the oil. Over the years, cast iron will soak up oil kind of like a sponge. So I want to get all that oil out so we've got good clean contact surfaces in here and don't have any problem with the braze material getting to where it won't adhere good or get contaminated. So just want to make sure that we've got good clean surfaces. So we'll do that also after I bevel the edges here. bevel around. We've still got enough contact surface in the center of the parts where they register against each other, so I'll be able to clamp them together while I'm getting the brazing done on them. So, let's get back over and melt some metal. So as you can see, I'm just using a handheld propane torch to heat up the part, and that'll let the oil wick out to the surface so I can wipe it off. And just took acetone, soaked on a paper towel, and rubbed the surfaces where we're going to be brazing. And I did that, I don't know, probably 4 times. I heated the part up and then went back with a acetone soaked paper towel, rub the surfaces off real good to clean them up, get any oil and contaminants, dirt, grit, anything that was on the surface off of there, and just getting it to where the flux is able to do a better job. Once you start heating the part up, getting ready to braze, the flux will do additional cleaning. It does much of what the heat and the acetone wipe that I was doing would do, but it even does more. It kind of does kind of like a shielding glass in other welding, where it protects the surface from oxidation, because as soon as the flux cleans the surface, oxygen wants to start the rust process with oxidation, and that would keep our braze material, in this case it's bronze rod, from adhering and flowing properly. So it's got multiple purposes, and just cleaning it off and getting the oil up to the surface and getting it out of the way first lets the flux do a better job, and that's what we're after. So a little bit of extra prep before you start trying to braze is well worth the time and effort to do it. It's very little effort, just a little extra time. You'll have a lot better success and have a lot more fun with your projects on your repairs. Well, I stuck this part down in the oil dry to let it cool off the rest of the way, and I'm going to take the angle grinder and smooth off these surfaces a little bit. This back side here was the only machine surface. I'm not sure it was machine. They may have just belt ground this down. Pretty sure I showed this in a previous episode about how this arm, the feed arm for the spindle on this Camelback drill, how it engages in the cogs here. And what we want to do is disengage it so it has no chance of engaging these cogs when the power down feed is in operation. So that was the purpose of getting that rod up there with the cast iron bracket that it's mounted into repaired, so that the lockout for the spindle's feed handle here can be disengaged and engaged against this rod at the top. Right now it's held open and it's disengaged. You can see it, it's not in any tooth there, but if we release it, it can come down and engage the teeth, which is what you don't want it to do when power feed's in operation. So I just wanted to mount it over here and show you how it was originally working before it got broken in transport. So I'll get it painted up and we'll call this a successful repair. Well, thanks for stopping by the channel, everybody, to find out what I've been up to recently. It's been a fun little project. I'm glad to get it checked off the list. And we've got power feed available on this old Camelback drill press now. So appreciate you watching. Like, subscribe if you haven't done so. Share the video with other folks you think might be interested, and I will see y'all next time.